Got it. All right, well, welcome everyone to the Dapr community call for September 7th, 2021. My name is Nick Greenfield, and I am an approver for the Dapr docs repo, and I will be the host for today's call. We have a pretty jam-packed agenda, so I think we're just going to get right into it with the content. So we have 4 topics today. We're going to start off with Ori talking about the recent announcement of Dappercon, what that is and when you can expect that. And then Yaron will talk about a new feature going into the 1.4 release, automatic encryption of state stores. And then Simon is going to take over with Dapr support in dev containers and Codespaces for components contrib, as well as running the quick starts. And then Dimitri is going to wrap things up, talking a little bit about scheduling configuration for timers and reminders in the after runtime, which is also something that's going to be in the 1.4 release as well. And then lastly, if there's time, we'll wrap things up with an open discussion. As a reminder, as always, all the participants are muted except for the presenters. So if you do have any questions during this call, feel free to leave them in the chat. And we'll make sure that we allocate time to address those after each topic or at the very end when we have the open discussion. So without further ado, I'm going to hand things over to Ori, who will talk about our first topic, which is DaprCon.
Yeah, thank you, Nick. So we're very excited about this. We announced the first ever DaprCon. So save the date for October 19th. And DaprCon is basically going to be the first ever virtual event for the Dapr community. And we're doing it almost exactly 2 years after Dapr was first announced. It was announced on October 16th, 2019. And the goal of that day is really to bring the community together. We're going to have a keynote. We're going to have some panels with maintainers, with people using Dapr. And we're going to have a few sessions, both for just if you're getting started or if you want to learn some best practices, but also if you want to see some examples from and learnings from organizations who are using Dapr to build real world solutions. So very exciting. As we get closer to the event, please keep an eye on the blog and on Twitter. We're going to share more details on the agenda. We're going to share more details on the speakers. So please stay tuned for more. We're very excited about this. And yeah, that's pretty much it. If you want to see the announcement of DaprCon, what we currently have out, it's on the blog. We had a blog post there a few days ago, and we're going to do, as I said, additional updates on the blog. So stay tuned.
Great. Thank you, Ori. No questions so far on DaprCon. Keep you posted. Next, Yaron, I think you were going to show a demo of the automatic encryption of state stores that we can expect in release 1.4.
Yep. Let me show the screen. And we can get started. Okay, let me know when it's coming through.
I can see it.
Awesome, thanks. So today we're going to talk about the new feature that's coming into Dapr 1.4, and that's automatic encryption of state. So if you want to research about the original issue, this is the GitHub issue in Dapr number 1090. You can look at the entire process of the design proposals and the discussions and all that. And that feature went in, and it'll be available once the 1.4 version is out. So why do we need automatic encryption of state? In a lot of enterprise workloads, especially in regulated environments, you want your state to be encrypted at rest by default. Now, some cloud databases provide that functionality, but a lot of databases, especially open source ones, don't. Especially open source databases that don't have like a paid for commercial offering, and even cloud databases that do offer some sort of encryption at rest using the cloud provider Even when that's available, in a lot of situations, regulations require developers to actually have the state be double encrypted. So encrypted at rest for backup purposes, but also encrypted with your own key that you bring for the data that's actually saved in the database itself, and that's not replicated to some sort of encrypted storage. And so Dapr comes out with this feature, and this is one of the Dapr features that really enhance databases and adds capabilities to it, even though that capability doesn't necessarily exist in the underlying database. So it's very much, like first write wins or the consistency settings that Dapr has. So that's pretty cool. And this actually supports all of the Dapr state stores. So like no matter which state store you're using, whether it supports transactions or actors or whatnot, you can have Dapr automatically encrypt data for your databases. And I'm going to show a demo of that in a sec. And we also support key rotations because obviously key management when encrypting secrets is something pretty important. So with no further ado, let's jump right into it. So the first thing we start off with is a configuration. Because this is still a preview feature, we're going to enable this very simple configuration here that leverages Dapr's capability to enable preview features. So we have this config here with the features, and here we're saying, hey, the feature name of state encryption is enabled to true. And this is what I have here in VS Code. This is the same configuration where it's set. And then the next thing is to just add this piece of metadata to any state store that I have with Dapr today. So I'm going to be running this locally. You can, of course, run this in any environment that Dapr runs in. This is going to be local. So this is my Redis state store. I have a Redis instance running locally with Docker right here. And let me just clear that. And you can see that we have the Redis host, the Redis password, all the regular metadata. And soon we're going to add the metadata entry for enabling encryption state. Now, I also have auth here. So I'm basically taking secrets from a local secret store. When I do Dapr init, when I install Dapr locally on my machine, we provision a local JSON secret store that you can put secrets in. And if we take a look at the secret store, this is the JSON file that I have locally. So here I have key 1 and key 2. We'll get to key 2 in a sec, but this is basically my encryption key. Now, Dapr uses a standard AES 256-bit encryption key, which is standard, and it's being used in Google Cloud, AWS, Azure, and a bunch of other cloud providers, and pretty much an industry standard for encrypting data at rest. So I have this key here in my local secret store that is saved locally, and I can put the secret into whatever secret store that's supported by Dapr. It can be Kubernetes, HashiCorp Vault, AWS, GCP, or Azure Key Vaults. And so I have this state store here. So let's see how we actually save state without having the encryption enabled. So I'm just going to run the sidecar here. And I'm just going to use the CLI. So I'm doing Dapr and I'm giving my application an ID. I'm calling it test encryption, and I'm pointing it to the components path that contains this state store. And this configuration path basically points it at the configuration file that enables the state encryption. And here we have the Dapr HTTP port, which is set to 3500, and that's going to be the HTTP port. So I don't have the encryption added to here just yet, and I'm going to run this. And now that it's running, I'm going to go into Postman. I'm going to call the local Dapr sidecar. So I'm saying, hey, Dapr, state API, please save state into a state store called state store. This is the state store that I have here. That's its name. It's very unique, very original too. And this is the body. I'm saving a key called well, and the value is hello there. So let's do that, and we can see that it is saved. Now I can go ahead and get that state. So I'm reaching out to state store, and then get the key, and we get back hello there. So that's great. And if you look at the Dapr logs, we can see that we loaded the state store component, and that's basically it. So now what I've went ahead and done is added the primary encryption key, metadata, and I'm pointing it to a secret ref. So that secret is being taken from the local secret store, which for my local dev machine, it's on the JSON file that I just showed you, and it's pointing at key 1, which is the key that we have here. So this is now going to extract the encryption key and then use it for every operation that we have. So let's go ahead and run Dapr again. And if I do that, and we look at the logs, we can see that now we have a new log entry, and it says automatic encryption enabled for state store with a very original name that I picked. And we can basically start using it. So what does this look like from a developer perspective? It looks exactly the same as if we were not encrypting state. So I'm just gonna post the body here. Let's actually do a hello there 1. And we finished, took 3 milliseconds, and I'm just gonna get it now. And it says hello there 1, only now encryption is being enabled. But what does the encryption look like? Let's try to remove the encryption and get the state back. So I removed the encryption now. I stopped the Dapr sidecar. I'm starting it again. Now I'll go to Postman and I'll get the state, and I can see that this time the data is encrypted. And I'm actually not getting the plain text, which shows us that automatic encryption is in place. So how do I rotate my keys? If you remember, let me just stop the Dapr sidecar here and go to the local store again. We have another encryption key. It looks very much like key 1, only if you notice, like this ends with 5 and this ends with 6 here. And so we have a different key. And so what I'm going to do now is go into my state store, and I will add a new metadata component, and I'm going to call it secondary encryption key. So I'm going to point my secondary encryption key to key 1 and my new encryption key to key 2. So any new data that now is going to get written or updated is going to have key 2 inside, and the secondary encryption key is being used to decrypt older values. So I can basically just save new values with the new encryption key, still read values that were encrypted with the old encryption key using key 1. And once this key falls out of rotation, when we finished all of our data migration, this key can basically just leave the secret store completely and just fall out of rotation. So yeah, this is basically the feature. I'm going to stop sharing now and take any questions if we have any. Glad you like it, Andrew.
Yeah, no questions. Looks like Andrew was excited to use it.
Yeah,
so
that's a pretty straightforward feature.
Yeah, it's pretty slick. It looks pretty trivial to use as well. Okay, if there are no questions, then I think we can move on to our second topic of the night.
Maybe just one comment, just to clarify though, that is coming in the next version, right? Version 1.4.
Correct. Automatic encryption will be released in 1.4.
Okay.
The upcoming release.
Okay, next we have Simon talking about Dapr with dev containers and code spaces, specifically with components contrib, as well as running the quick starts. And as I forgot to mention, this is currently available, and let's dive into this deeper, but yeah, currently available as our latest release of 1.3. So Simon.
Thanks, Nick. So let me get my screen share going. Hey, so I'm assuming folks can see my screen. Like Nick mentioned, this is actually a feature that we've had in the code base for a while now. And the reason we're starting to talk about it right now is because Codespaces as a feature has recently just been made generally available to everybody. And for those of you who are not familiar with Codespaces, it's really a cool new GitHub feature which allows you to use Visual Studio Code backed by these performance VMs in the cloud. So you don't have to go and set up your dev machine anymore. You don't have to go download Visual Studio Code. It basically takes the feature of developer containers that Visual Studio Code supports locally on your dev machine and gives you all that power backed by a cloud VM, right? And so some of you may be familiar with some of the code bases that had dev container definitions already. So for example, the Dapr project and the Dapr components contrib project both had dev container definitions, right? And what that meant was, as a developer, you can say, hey, I have my host dev machine, but I work on a lot of different kinds of code. I work on Java code, I work on Go code. And for a cross-platform project like Dapr, you kind of want to make sure that you have the right versions of the tools to work on your particular application or to work on a different kind of project. And dev containers make it a really useful way to keep your development environments clean. So you can have specific versions for compiler or specific versions for toolchain in a container that you can remote into from Visual Studio Code natively and work as if, you know, all of that developer tooling is on your host machine itself, right? Codespaces effectively takes that idea and, you know, puts it into the cloud. And so I think it's a little bit hard to explain without actually getting into the demo. So we'll just jump right into that. For Dapr, really, there's sort of two major use cases that we are trying to support with dev containers and Codespaces. And this is where the feedback from the community would probably be really helpful. I'm going to show you what it looks like to use the Codespaces specifically for quick starts. And this is you're a user, you kind of want to learn Dapr for the first time, but you don't want to go through all the effort of setting up your machine, right? Like I don't have to download a whole new toolchain just to figure out if this Dapr thing is going to be useful for me or not. So here we have the Dapr Quick Starts project. And you'll notice that the code button now has this Codespaces tab underneath it, right? And from here, you can actually just click New Codespace. And what this will do is, most of us, like you see, I don't have permissions to push to the Dapr project, of course. So if you do click on the New Codespace button, what it will do is actually create a fork in your personal account. And it will then create this code space in your fork. So you don't have to worry about messing up anything in the main Dapr project. This is all going to be spawned in a fork for you. In the interest of time, I'm going to go and hydrate a dev container that I've already built earlier. So if you go back to the previous one, you'll see that I already had a dev container set up. And the Codespaces are both supported online in terms of I can run this entire experience, this fully rich UI experience in the browser itself, or you'll see that big giant green button that says you can also open a Codespace in a local install of Visual Studio Code. So just for the purposes of this demo, I'll show you using it inside this environment. And one of the things we're going to start doing right now is show you that we have all the tooling basically set up for you to run the quick starts, right? Like it's got all the SDKs, it's got Python, it's got Node.js, it's got Go, it's got pretty much all the pieces that you need, the prerequisites that we talk about in the quick starts pages right here. So right now, for example, if I want to start doing one of the quick starts, let's say I want to go and do the Hello Kubernetes quick start, right? Look at the prerequisites. It says you need kubectl there. We have Minikube, and I'm just spinning up a new cluster in this environment already. The tooling that we provide for all of this stuff is sort of tuned to basically everything that you should need to make any of the quick starts work. And this is both the self-hosted examples as well as the Kubernetes-based ones, right? So the idea is for this to be super lightweight. A lot of this has been mostly me trying to play with it. So if folks do come across any issues with this, definitely file the issues for us. We really want to lower the bar for folks sort of getting to experience what it's like to use Dapr in these environments, right? So like right now we have this already, Dapr is also already installed. And if you look at the version, it's currently, the tooling is basically the latest versions, and we expect that 1.4 tooling will be automatically updated in the dev containers and in the code spaces as well. And so I can just go straight to Dapr init, okay, and it will now deploy Dapr into my freshly minted cluster on this code space, and this is all running in the cloud on the VM. If I want to go and look through the rest of this, quick start, for example, I can start following the steps. So like the next step says, go Dapr status K, and I can do that. And it shows me, oh, I need to wait a little bit more before Dapr is actually up and running on this. It says, oh, go follow these steps to, set up Redis, right? And in terms of time, I basically have those set up, so I can just paste them in. And yeah, I have Helm's available. I can deploy Helm charts into my system. Some things, of course, are slightly different than when you're trying to use this thing locally. One of the things, for example, you'll see a lot of is that we kind of expect that you have localhost. And this being a remote machine, you might wonder, okay, does that work? And it does actually. It does behave a little bit differently. So for example, let's say I want to go and do hello Kubernetes, right? One of the things I want to do is probably I want to start applying the various deployment configurations that I have. TL apply. Right, so I can do this for Redis. I can do this for, let's say, Node. And one of the things I want to figure out now is, well, actually, I should probably wait until the Node deployment comes up. So let me check on that to see if that's up and running. Yeah, so what's coming up? You'll notice in the little corner here, there's a ports tab, right? And what Codespaces does on your behalf is it will actually do the proxy forwarding for you. So you'll see that I have all these containers set up already, and a lot of these are for the Dapr, namespace containers. And now that I have this, the next step in the tutorial, for example, tells me that I really want to go in, make sure that I have the port forwarding enabled, right? So if I do that, so we now have port forwarding. Oh, let me open a different dash window. You'll notice this little pop-up comes up and says, oh, open this in browser. And that actually says there's no, because we don't have get, but if we actually use a route that's available to the app, I think ports is something that's exposed by the app. You'll see that actually, the URL is basically this redirect that comes from Codespaces itself, but you basically get the responses from the application that's running on that machine as if it's localhost. So continuing sort of on that example, you can basically do all the standard curl things that you might want to do. So for example, the next part of that is I want to go make a curl request, right? And we can then go and check if the curl request actually succeeded here. And like you can see, it actually does work. So really, the one thing that's sort of slightly different in a Codespaces environment is this sort of network proxying. And you also see this for the next step, where if you do the dashboard, oops. I'm having some latency connecting to this machine. Okay. Yeah, you'll see that it fails, but then you'll get the redirection. And when you open it in the browser, you'll see that the dashboard actually does come up. So that's just something to be aware of in the Codespaces environment. And like I mentioned before, the Codespaces definitions are really based on dev containers. And so you don't have to actually use this in cloud if you don't want to. All of the dev container definitions are already available in the repos themselves. And so the next demo I'm going to do really is, well, how do you use that locally? So let's say I've got Visual Studio Code installed already. I don't want to go install like all the other developer tools on my host machine because I'm using it for some other development work, right? What do I do? Well, here I have a local a copy of the fork of my repo, which is components contrib. And when I basically bring it up, one of the things it should be doing is it should figure out that I do have a dev container. And yep, you'll see that it comes up and prompts me as to whether I want to reopen this in a dev container, right? So you can click on the button there, and it will basically take this dev container.json file, and it will start to spin up a container image and automatically remote into that image on my behalf. So it looks like I have this completely local experience. If you've used the remote development extension before in Visual Studio Code, that's the exact experience that you'll have here, right? And also, you heard me mention the remote development experience. You do actually need the extension for that. I believe the Visual Studio Marketplace now has that packaged together in a single one, and that will include WSL remote development, SSH remote development, and as well as container remote development. So as long as you have that extension, you should see that pop up. Or you can then go into, for example, this little container icon, and you can run your dev containers manually from here. So yeah, it's a little bit slow on my machine, but yeah. So this is, for example, the dev container I'm running right now. And really, again, the idea is once you're in here, the thing is pathed correctly. The thing you do have to look out for on Codespaces is Codespaces, we don't have the ability to actually automatically do the pathing for you. So you actually have to go and change directory yourself manually to get here. But in this one, what has happened is the local copy of my repo has been mapped into the dev container. So this is actually all of the files that's on my host's drive. And this is basically mounted, right, mounted into the container itself. So all the other tooling is really ready for me to use. I can, for example, just go and do a make lint here, right? So the right versions of the Golang linters are already on this machine. I can go run that. That might take a while. So while that's running, we can also go and take a look at the other tooling that's involved, right? And you can even do like your regular debugging. So Delve is already available on this. I should note specifically that for components contrib and for the Dapr repo itself, this is much more focused on the contributor experience. So we largely expect folks who are looking at those particular repos to be interested in, actually developing a component and adding that into Dapr. And so a lot of it is a little bit more technical. It is much more towards you've read the contribution docs and you want to be able to run tests easily, right? So again, I can just come here and do make test, and it will basically run the test. Like for example, these are all the lint errors that we've found. I can actually go and say, I want to create a launch.json. So if you use Visual Studio Code, one of the great things is you have this visual debugging experience, and you can just say, well, I'm going to create this launch.json file. A caveat is the Visual Studio Code uses the debugger adapter, which is not installed by default. And so you're going to have to manually, you will get prompted the first time you run a debug experience to go install it. I've already done on this machine, so you're not going to see the prompt pop up. But as it starts to load the debugger and to actually build the application, you'll see, yeah, this is all in the dev container. You have a full debugger experience. You can do your standard, F10 step over. You can step into specific functions, right? And you can continue. F5, and oh no, I've hit a panic, and all this stuff, exception handling, all that, works correctly in this space. It's like, that's strange. Why did I hit a panic? Well, okay, well, couldn't actually find this thing, right? So maybe let's stop that for a moment. And it's like, oh, of course, I didn't run the actual service. Like this is actually expecting there to be like the SQL service running for this test to complete. You can also do a bunch of these things on the command line, right? Like this is a full-fledged development environment. So let's say I actually want to go and run the environment. I can actually do the Docker compose. So both the Codespaces and the dev containers right now use a Docker and Docker configuration. What that means is you have Docker in the host, right? And so if you actually do like a Docker stats.
Simon, can you make your screen, the font a little bigger maybe?
Oh, yes.
Thank you.
Oops, maybe too big. that better?
Yeah, thanks.
You'll notice that, for example, when I do a Docker stat, it only shows the container I just set up, right? And whereas you would expect that because I'm running this in a container, if this was the host's view of the Docker, it would also show the container I was running, which is where I'm doing my development work in. So now I've got my actual test application running, or the service that my test application expects running. I can also go and do the debugging on the command line itself. So I can run delve on the command line. It's going to do build. It's going to build comp test again. Right. So now from here, if you prefer, I can do like standard things. I can do that. I can do server go, I think. Oh, okay. So that line number actually works. And then you can continue. You can do backtrace. You can do all the things you expect, with the tooling that's available to you here, right? And so actually, if I just continue, hits both breakpoints and it runs to completion now. And so try it. This is basically all set up for folks to enable folks to have an easier time getting started with a bunch of the difficulties doing this. Components contrib, I will also call out, has a special property. If you've tried to contribute a new component before, you'll notice that you actually do need to have the Dapr repo as well. And one of the things that the dev container does on your behalf as well, it also does a clone of that repo for you. So if you look at this, there's a clone of the Dapr repo. There are a bunch more things you can do with this in your own environment. For example, if you have both Dapr and components contrib locally, you have forks of those locally, and you actively develop on them, you can actually go into the dev container JSON file, and you can actually do a mapping of both of your local copies of that into a single dev container environment. A lot of these things are going to be in extra links just to keep the demonstrations short. So the following slide will have a bunch of extra resources. Please go read up on it. Please go send us any questions, especially in Discord, and let us know what you think of it. Any questions folks have right now?
I'm not seeing any questions in the chat, but this is definitely cool. I can see how these packages, your dev environment packaged up, can really help expedite getting in and getting into components contrib.
Yeah.
Cool. Well, thank you, Simon.
Sure. And on to the next speaker.
So this was the slide that Simon was referring to. I'll leave this up for a second for anyone who wants to follow up with any the things that Simon was mentioning. So Codespaces, dev containers, how to contribute to Dapr. Yeah. Okay. And our last topic is Dimitri, which he'll be talking about scheduling configuration for timers and reminders in the Actor runtime. And this is slated for the next release 1.4 as well. So Dimitri.
Yeah, hi, hello guys. Let me start sharing. Can you see my screen?
We can.
Yeah, great. So yes, I will be talking about scheduling consideration for timers and reminders. I will start with some history. We started this work because of the issue that has been raised approximately 7 months ago, and the long story short, the ask was to allow timers to stop working at certain conditions, because at that time, to enable that functionality, users had to create another reminder or timer to kill the first one and it wasn't convenient. Independent of that issue, Jigar implemented a feature in reminders that allows to limit number of repetitions, and he implemented that by using a ISO 8601 format of duration. So it was a great feature, but it only was applicable to reminders. And what we wanted to do is we wanted to have identical standard experience for timers and reminders because of the very similar nature of those two. So what we end up doing is we created certain very simple algorithm how to configure both timers and reminders in the same manner. So some of the parameters you can see they are present today. Some of them will be available in release 1.4. But so the common flow of timers and reminders, once it is registered, we want to allow some time to pass to activate the timer or reminder, and then we want it to fire every once in a while, which is a period. And once certain time has passed or certain time passed, we want to stop. We want the option to stop timer or reminder and remove itself from the runtime. So this is the parameter that we now allow users, or we will allow users to define starting 1.4 release. Due time is a parameter that sets either absolute time or duration after which the timer and reminder will be activated. And we support 3 different formats for that. We support RFC 3339 format to set absolute time, or we support time.duration. It's a format used in Go language. It's just a simple format that specifies the duration. Or the third option is ISO 8601 duration. So ISO 8601 itself has multiple formats for to specify time intervals, including absolute and relative time. We only use duration in this feature. So that's for due time. Period again is the optional parameter to set time intervals between 2 consecutive callback invocations. And we support in 2 formats. First is time duration, and second is ISO 8601. And we support 2 variants. The first one is just to specify duration, and second to specify duration and number of repetitions. And this is aligned with the change that was done by Jigar. And third parameter is TTL, time to live. As the name suggests, it will specify absolute time or duration after which timer or reminder will be stopped. So similar to due time, we support 3 formats for this parameter: absolute time or duration in 2 different formats. So the actor runtime will validate the correctness of the configuration, whether it's the syntax is correct, or if time does not make sense, or if the syntax is not correct, in both cases, it will return error. And if we have both number of repetitions and TTL specified in configuration, we will stop timer or reminder on the first occurrence on the first event that will happen. Either a number of repetition or TTL will expire. So all these parameters are optional. So if we don't have any staging configuration, then the callback will be invoked right after registration and only once. The second from the left example, we set due time and period, meaning that we will be waiting, in this case, 9 seconds, and then we will be fire, or will be invoke the callback every 3 seconds. The third example, in third example, we only set period, and in this format, we limit number of repetition to 10, meaning that there will be only 10 callbacks set apart in 3 seconds. So next on the right column, the first example, we are setting period to 3 seconds and TTL to 20 seconds, meaning that once the timer or reminder is registered, it starts firing every 3 seconds, and after 20 seconds, it will be stopped. And the last example is we have due time, period, and TTL. So in this case, we will be waiting 10 seconds, and we will start firing every 3 seconds, but for the duration of 10 seconds, but no more than 4 times. So whatever comes first, whatever condition comes first, that will signal the runtime to stop and delete the timer. So one caveat is that we are not counting the time spent in the callback. So if the period is set to certain value, for example, 5 seconds, the runtime will call that callback every 5 seconds. So if, for example, the callback for some reason takes more than 5 seconds to complete, then the runtime will receive that the next callback right after the first one is completed. That's I think that's yeah, that's it from my side. This feature, like I said, will be available in 1.4. We will be updating documentation with more information, and as always, we are here to answer all questions now or later in through the portal.
Awesome. Well, thank you, Dimitri, for running through that. We look forward to it in 1.4. And with that, let me share my screen. With that, that concludes our topics for the evening. I don't think there was any questions pertaining to the last Dimitri's topic, not that I see in the chat there. So I guess we'll just move into the open discussion now. It looks like there's one question from Long. I have a question. They use Redis for real-time cache, which is sensitive to latency. The gRPC codec from Dapr introduces unacceptable latency. Is there any thought about that? And I can already see that Artur is asking more for some more details regarding this scenario, whether it's state stored, pub sub, or binding. Don't know if Long is still with us and can provide that information, or if anyone else has any thoughts around the question. Artur, I will mute you just so you have.
Yeah, thanks. Yeah, so thanks, Dimitri, for the presentation. Like, I like how you show the difference between due time repetition. Was very clear. For the question from Long Day, I think it, like I said in the chat, like it's good to know like what is the context here. If it's like, because we read it from multiple building blocks, so I'll understand the scenario a little bit better. Just reminded that Dapr adds about a little bit less than 2 milliseconds on latency for service invocation. So we need to know exactly what's the scenario, and we can add additional performance tests into Dapr, just validate exactly which scenario he is referring to.
Yeah, and Arthur, you mentioned correctly that around 2 milliseconds is for service invocation. For one app to reach into Dapr, it's less than a millisecond. So yeah, I'm really going to join in on your question as to like what's the expected latency there.
Yeah,
because it should hardly add anything at all.
Yeah, and then
on top of native Redis.
Another thing that we noticed is that we noticed this today also in one of our E2E tests, is that sometimes the application forgets that it can reuse a Dapr client, and then it taps a connection per message, and that adds a lot of latency unnecessarily because of all the connection handshaking and everything. So if you reuse a Dapr client, if you use the Dapr SDK, you should reuse the Dapr client because there are optimizations built in to reuse connection for invocations into Dapr SDK. So into the Dapr API. So just a reminder that the Dapr client SDKs are reusable by design. I'm not saying that's what's happening with Long Day, but just like it's an easiness. We've seen this happening many times, including to our own test code.
So, Arthur, how do you recommend Long following up with you on this? So should we open?
Long it has a open communication with us, so he talks to us through GitHub and also through Discord, and also in a one-on-one messages. So he will follow up for sure because he's very proactive in reach out to us.
Okay. Any other? This is an open discussion. So any other topics top of mind that any folks in the call would like to ask? Not seeing anything. So with that, I believe that concludes our community call for today. Thank you everyone for joining, and we will see you in the next one.